Welcome to another deep dive, and today we're going to be tackling the multiverse.
Oh, always a fun one.
Yeah. We're looking at a 2004 paper by Don N. Page. It's called Predictions and Tests of Multiverse Theories. So we'll be talking about what multiverses are, why some scientists think they exist, and maybe how we can test these theories.
Sounds like a plan.
So probably a lot of you listening have heard about the idea of multiple universes, maybe from sci-fi or whatever, but it's something that scientists are actually taking seriously.
Yeah.
And it starts with what they call the fine-tuning problem. Basically, the idea is that all these physical constants in our universe seem perfectly calibrated for life to exist.
That's right. Like the strength of gravity or the mass of an electron, if you change those even just a little bit,
Yeah,
the universe would be completely different. We wouldn't be here.
exactly. So how do we explain this? It's like someone carefully set all these dials to make sure we could exist.
Right. So there are a few main explanations people have come up with. One is this idea of a fine-tuner, like maybe a god or something intentionally setting things up this way.
Okay.
Another one is just pure coincidence, like we just got super lucky.
Yeah.
And then the third one is the multiverse, the idea that our universe is just one of many, and they all have different physical laws.
So basically, it's not surprising that at least one universe got it right,
Yeah.
and we just happen to be in that one.
Exactly. And it's worth pointing out that these explanations, they don't necessarily rule each other out. It's possible, maybe, a fine-tuner created a multiverse. And even if you just stick to science, the fact that there are so many of these finely tuned parameters,
Right.
pure coincidence, starts to seem pretty unlikely.
Yeah, I can see that. Now, earlier you mentioned string theory. How does that fit in?
Well, string theory or M theory, it's kind of the leading candidate for a theory of everything. You know, it's trying to explain all the fundamental forces and particles in the universe.
Right.
And a lot of physicists think that string theory actually needs a multiverse to really make sense.
So you're saying this theory, the one that's trying to explain everything, might actually require multiple universes to work.
Yeah, that's kind of where the math seems to lead.
Wow. But here's the thing that always gets me about the multiverse. If we can't see these other universes, how can we even talk about them scientifically? How can we test any of this?
Yeah, that's a common question. But think about it. We can't directly observe black holes either, but we can see their effects on nearby stars.
Right.
And that evidence supports the idea that black holes exist. It's the same with the multiverse. A good theory that uses the multiverse should make predictions about things we can observe in our own universe.
Okay, I see what you mean. So it's less about trying to actually see another universe and more about looking for clues in our own universe that point to something bigger.
Exactly. We're looking for the fingerprints of the multiverse, so to speak.
Okay, that makes sense. But then what kind of predictions are we talking about? How do you test a theory about something like the multiverse?
Well, that's where this concept of measure comes in. For any multiverse theory to make testable predictions, it needs a way to assign probabilities to different observations.
Okay.
Otherwise, anything goes, and the theory isn't really saying anything.
So it's not enough to just say, hey, maybe there's a universe where gravity works differently. You need to have some way to say how likely that is.
Exactly. It's like trying to understand the weather. You can't just say, it might rain tomorrow. You need to say, there's a 30% chance of rain.
Right. But I imagine figuring out a measure for the multiverse is, well,
Complicated.
yeah.
Very much so. And it gets even more complicated when you bring in quantum mechanics. Don Page, he proposes this framework called sensible quantum mechanics, or SQM. And this is where things get really interesting, because SQM says consciousness is actually part of the picture.
Hold on. Consciousness, like our awareness, how does that fit into all of this?
I know, right? It's pretty wild. SQM basically says that true observations are like fundamentally acts of conscious perception. And each set of these perceptions has a corresponding awareness operator, like a mathematical thing that goes with it. It's like each time you become aware of something, that act of perception has a certain weight in the multiverse.
So you're saying the act of us observing something could actually influence the probability of that observation happening in the multiverse?
That's the basic idea. It's a radical concept, I know.
It is.
But Page argues that in a multiverse, we have to take consciousness seriously if we want to make real predictions.
Okay, so these awareness operators give us a way to measure observations. But how does that help us figure out if a particular multiverse theory is actually correct?
Well, that's where we run into another challenge, the problem of infinity. You see, if the multiverse has infinite space and infinite possible conditions for life to arise, You could end up with infinite observers.
Right.
And if you have infinite observers, you might end up with infinite measures for most observations.
Oh no, infinity. Back to high school math class, struggling with calculus.
I hear you. Infinite values make it really hard to compare different theories and figure out which one is best. I mean, how do you even calculate the ratio of two infinities? It's a headache.
So how do we get around this problem of infinity? Is there a way to make sense of these infinite measures?
Well, Page suggests this clever solution, a concept called typicality. It's a way to take those tiny probabilities, or even zero probabilities, and turn them into something we can actually use for testing.
Okay, I'm intrigued. How does typicality work?
Imagine you're plotting all the possible values for, say, the Hubble constant, the thing that describes how fast the universe is expanding.
Okay.
Typicality basically measures how likely a random observation is to be at least as extreme as what we actually measure.
So instead of asking, what's the chance of getting this exact value, we ask, what's the chance of getting a value at least this extreme?
Right. It's like winning the lottery. It's crazy unlikely to win with your exact numbers, but the chance of someone winning is actually pretty high.
Right. Typicality lets us look at those broader chances in the multiverse.
That's actually a really cool way to think about it.
Right. And to understand how we might actually use this, we need to bring in Max Tegmark's classification of multiverses. He describes 4 different levels.
Oh, yeah, I've heard of those. There's level 1, which is basically just regions beyond our cosmic horizon. Then there's level 2 with other bubble universes that maybe have different physical laws.
Yes.
Level 3 is where you get into the many worlds interpretation of quantum mechanics. And then there's the big one, level 4, which includes all possible mathematical structures.
You got it. Now, what's really interesting is that Page argues that, from a purely mathematical point of view, any multiverse theory could, in principle, be reduced to a single, really complex universe.
Really? So a single universe could contain all the same possibilities as a multiverse. That's the idea. But it might be a lot simpler, more elegant, scientifically speaking, to describe it using the language of multiple universes. It's like it might be the most efficient way to capture just how vast and complex everything really is.
So even if we could describe everything with a single universe, using the idea of a multiverse might be the better way to do it.
Exactly. It's about finding the most concise and elegant way to explain it all. But here's the real kicker. Even if we accept the idea of a multiverse, or even multiple multiverses,
Wow.
we still need a meta-theory to explain what the measure is across those universes. We can't escape this fundamental question of why our reality is the way it is.
So whether it's one universe or a multiverse with infinite possibilities, we're still left wondering why this particular reality with these specific laws and constants is the one we experience.
Exactly. And Page argues that no matter how many layers of multiverses you add, you always need some fundamental theory to provide the answers. The question just changes from why these equations to why this measure.
Wow. Okay, we've covered a lot of ground today. We started with the fine-tuning problem and this appeal of the multiverse. Then we talked about measure and how hard it is to test these ideas. We even touched on the role of consciousness in quantum mechanics, which is definitely something I'm going to have to think more about.
Welcome back to our deep dive into the multiverse. Last time, we were talking about how tricky it is to test these theories, especially when you're dealing with, like, potentially infinite multiverses.
Right. It's like, how do you even start to think about infinity, let alone try to make scientific predictions about it? But I'm really curious about something you mentioned earlier, this idea of typicality. You said it was a way to tackle the problem of infinities.
Yeah. So think of it like this. You have a dartboard. And this dartboard, it represents all the possible values for some physical constant, like the strength of gravity.
Okay.
Now, in a single universe, you'd expect that constant to have one specific value, right? Like you hit the bullseye on the dartboard.
Yep.
But in a multiverse, you could have tons of different universes, each with its own value for that constant. So now your dartboard is covered in darts all over the place.
So instead of looking for one specific dart, we're dealing with a whole bunch of them.
Exactly. Now, typicality says, instead of asking, what are the odds of hitting the bullseye, which might be super tiny, we ask, what's the probability of a dart landing at least as far away from the bullseye as our universe's value?
Oh, okay. So basically, we're looking at how typical or unusual our universe's value is compared to all the other possibilities.
Exactly. It's like asking, how likely is it for a dart to land at least this far from the center? rather than what are the odds of it landing on this exact spot.
Right. That makes a lot more sense, especially if you have like infinite dartboards or, multiverses.
Precisely. It lets us compare things even when the probabilities are crazy small, even zero sometimes.
So using typicality, we can actually start to test these multiverse theories, see how well they match up with what we observe.
Yeah, that's the idea. Now let's switch gears for a bit and talk about something specific we might look for, some actual evidence for a multiverse.
Okay, what kind of evidence?
Well, one really interesting possibility is in the cosmic microwave background radiation, the CMB.
Ah, the CMB. That's like the afterglow of the Big Bang, right?
Exactly. It's this faint signal that's everywhere in the universe, and it tells us a lot about what the universe was like way back when.
So what does the CMB have to do with the multiverse?
Well, some multiverse models, they say that our universe might have actually collided with other bubble universes a long, long time ago.
Wait, are you saying our universe like bumped into another one? Like a cosmic fender bender?
Yeah, it sounds wild, but it could have happened. And if it
Mhm.
did, these collisions, they would have left these faint marks on the CMB, tiny changes in temperature and polarization.
So it's like looking for bruises, basically. Remnants of these ancient collisions.
Yeah, pretty much. And those signals, they would be super faint, hard to detect. But the surveys we have now and the ones planned for the future, they might just be sensitive enough to pick them up.
Wow, that would be incredible. Like completely change how we understand the universe.
Totally. A real game changer. But it's important to remember this is just one example. There are other ways we might find evidence. And as our tech gets better and we understand the universe more,
Yeah.
we'll be able to explore these ideas even further.
This is blowing my mind. I mean, what other secrets are out there? It's amazing.
It is. It's a testament to science and human curiosity, how we keep pushing the boundaries.
Absolutely.
Yeah.
We've talked a lot about the science, but I want to circle back to something we touched on before, the philosophy of it all. What does it mean if we actually find evidence for a multiverse? Like, what does that say about us, about our place in, well, everything?
Right, yeah. Does it make us less significant if our universe is just one of many? Or maybe it makes us even more special?
Exactly.
It's a huge question, and there's no easy answer. Some people might say, well, a multiverse makes us less special, less unique, like a grain of sand on a beach.
But others might say, wait, the vastness of it, all the possibilities, that makes us more remarkable. I mean, how improbable is it that we exist at all?
Exactly. It also makes you think about what real even means. If there are all these other realities out there, maybe with totally different laws of physics, different ideas of time and space, what does it even mean to be real?
Whoa. Yeah, it really challenges everything we think we know.
For sure. It makes us confront the limits of our understanding. Maybe there are things out there that are just beyond our grasp.
I think that's a good place to pause. It's a lot to process. Just the sheer scale, the complexity of the multiverse, it can be overwhelming. But it's also incredibly inspiring. Think of all the possibilities out there.
It is. We've covered a lot today. The fine-tuning problem, this idea of typicality, potential evidence for a multiverse,
Yeah.
and then all these deep philosophical questions.
And we've only scratched the surface. There's so much more to learn. I'm excited to see what the future holds, what discoveries are waiting for us. Welcome back to our deep dive on the multiverse. We've been exploring some pretty mind-blowing ideas, and I have to say, I'm still processing it all.
It is a lot to take in.
It is, but it's what makes it so fascinating, right?
Absolutely. It really challenges how we think about reality, makes us consider things that might seem like, pure science fiction.
Yeah. When you first mentioned the multiverse, I'll admit I was skeptical. It just seemed like something we could never really prove or disprove. But as we've been talking, it seems like there are actually ways we might find evidence.
Exactly. And the more we understand the universe, the better our technology gets, the more precise our tests can be.
Right. So let's talk about some of those potential tests. You mentioned the cosmic microwave background radiation earlier, that it could hold some clues about the multiverse. Could you maybe expand on that a bit?
Sure. So the cosmic microwave background, the CMB, it's basically this faint afterglow of the Big Bang. It's everywhere in the universe.
Yeah.
And it's like a snapshot of the universe when it was incredibly young, like a tiny fraction of a second old.
And this snapshot, it could contain evidence for the multiverse?
It might. Some multiverse models, they predict that our universe could have collided with other bubble universes way back in the past.
Uh,
And these collisions would have left behind these little imprints in the CMB, like imagine dropping a pebble in a pond, the ripples that spread out.
oh, I see. So we're looking for these tiny ripples in the CMB that could be signs of a collision with another universe.
Exactly. Like a form of cosmic archaeology. We're searching for traces of these ancient events that could tell us about something beyond our own universe.
That's wild. Now, these signals, I know they would be incredibly faint, but are there any experiments, like currently happening or planned for the future, that could actually detect them?
Yes, there are. Several cosmological surveys are going on right now, and even more are planned. They're mapping the CMB with super high precision, trying to capture every detail.
So there's a real chance we could find evidence for the multiverse, maybe even in the next few years.
It's possible. And if we did, it would be a huge deal, one of the biggest discoveries in human history. I mean, it would totally change how we understand everything, our place in the universe.
Wow, that's pretty incredible. Now, aside from the CMB, are there any other ways we might be able to test these multiverse theories?
Yeah, actually. Another promising avenue is looking at the values of fundamental constants.
Fundamental constants, okay.
These are like the unchanging numbers that control the laws of physics.
Yeah.
Things like the speed of light, the strength of gravity.
Right.
Now, in a single universe model, those constants, well, they could have any value in theory. But if you have a multiverse with all these different universes and their own sets of laws,
Yeah.
you'd expect to see a certain distribution of values for these constants across the multiverse.
So basically, if the values we measure for our constants seem statistically unlikely in a single universe model, but they fit better with a multiverse scenario, that could be a sign, right?
Exactly. It's like, think about rolling a die. If you roll a 6 once, no big deal. But if you roll a 6 1,000 times in a row,
Yeah, something's up.
right, you start to think maybe there's something more to it.
I like that analogy. So by carefully measuring these fundamental constants, we might be able to get some hints about the nature of the multiverse.
Exactly. And the more accurate our measurements get, the better we can test these theories.
This is all so fascinating. It feels like we're on the verge of some really big breakthroughs in our understanding of, well, everything.
It does, doesn't it? And even if we don't find definitive proof of the multiverse, just exploring these ideas, it's pushing the boundaries of science, expanding what we thought was possible.
Right. We've talked a lot about the scientific side of things, but I also want to touch on the philosophical implications.
Ah, yes. The big questions.
What does a multiverse mean for us, for our understanding of reality, our place in the cosmos?
It raises some profound questions about the nature of reality, the meaning of existence. It challenges our whole view of the universe, makes us realize we might be just a tiny part of something much, much bigger.
It's almost impossible to grasp the sheer scale and complexity of it all. But it's also incredibly awe-inspiring, all those possibilities out there.
It is. It forces us to confront our limits, to accept that there might be things we can't fully comprehend.
It makes you wonder, about other forms of life, other kinds of consciousness that might exist in these other universes, what their reality is like, what laws of physics they might have.
It's a humbling thought, isn't it? It reminds us how much we still don't know about the universe, how much there is to discover.
And that's a beautiful thing, isn't it? This sense of wonder, this drive to explore the unknown. Each new discovery, it brings us closer to understanding our place in this vast, amazing cosmos.
Absolutely. And as we continue this journey, I think it's important to approach it with a sense of curiosity, humility, and a willingness to embrace the unknown. Because if the multiverse does exist, it's a testament to the incredible creativity and complexity of the universe, something far beyond anything we could have imagined.
Well said. I think that's a perfect note to end on. We've really delved deep into the world of multiverse theories, explored their implications, and wrestled with some pretty big philosophical questions.
It's been a fantastic journey. And while we may not have all the answers yet, one thing's for sure, the search for understanding, the quest to unravel the mysteries of the multiverse, it's an adventure that's just beginning.
And who knows what amazing things we'll find along the way. So to everyone listening, keep exploring, keep questioning, and keep your minds open to the infinite possibilities that the universe holds.